my name's Jacob, and on behalf of encoord, welcome to the third video in the Intro to Saint video series. These videos do build on one another, so if you have not watched videos 1 and 2, please watch those before watching this video. In this video, we're going to cover Saint scenarios. I like to use the cake analogy to describe what a network and a scenario are in Saint. So the crumb of the cake is like the network, but you can make lots of different cakes by applying different frosting. So the frosting is like the scenario. Functionally, this means that we can have a base network on top of which we apply different scenarios to do many different types of modeling and gain many unique insights using Saint. Now, cute analogies aside, let's look at this a little bit more specifically. Here we can see the gas, electric, and thermal networks, which are stored in GNet, ENet, and TNet files. On top of the networks, we apply different scenarios, such as gas scenarios, electric scenarios, and thermal scenarios. Those can be stored in the GSCE, ESCE, and TSCE files. The results of these scenarios are stored on the solution level. So you can see that there are gas solutions, electric solutions, and thermal solutions. These solution files are a database of results that are written and queried while using Saint. I think all this will really come together with an example. So given that I have my network open, in this case I'll use the ENet39, the ask is to open the PCM peak demand week scenario. Let me show how to do that in the GUI. Here is the GUI in the same state that we left it from the last video. If I didn't have my network open, I would have to open it using the network open electric network. But in this case, I know my electric network is open because I can see it ENet39 down here, and I can also see the information on the map and in the Model Explorer. The ask of this example is to open the PCM peak demand week scenario. So I will go up to my scenario tab and I will open my electric network scenario. I can see by default there are a handful of different scenarios included with this model ready dataset. I was asked to open the PCM peak demand week. Now I have opened my PCM peak demand week scenario. I know it is open because I can see the information in the bottom left-hand corner of Saint. I also know that my scenario is currently solved. It is in the state of solved because it found a solution file like I had mentioned on that previous slide. Now there are many types of scenarios. Let's look at some in the documentation. Picking up from where we were in the documentation in our previous video, let's navigate up to Layers and Scenario. On this page, we can see an exhaustive list of all the different scenario types, including ACPF, ACOPF. All of these will be subjects of future videos. For this video series, what we need to understand is that scenarios allow you to unlock different modeling domains in Saint. So, for example, in an integrated planning workflow, you may have a common network on top of which you apply production cost models to simulate the operations of your grid. And then you may apply a steady state AC power flow case to simulate the actual physics of that operation that you simulated with your production cost model. So again, the idea is that you have a common network model and you can apply different domains or different scenarios to that common network. Within each type of scenario, there are a variety of settings. We can see these settings outlined in the documentation. If we go to Docs, Reference, which we're already in, Scenario, electric scenarios, and let's use the DC unit commitment optimal power flow, DC UCOPF scenario as an example. Here we can see an exhaustive list of the common settings within the DC-UC-OPF scenario. To find these exact settings in the GUI, I can navigate up to my Scenario tab and open the Electric Scenario Editor. Here I can see a window of all the current settings of my PCM peak demand week scenario. Some common settings in production cost modeling, or DC-UC-OPF, can be found at the bottom. For example, we can see this as a MIP problem. We can see information about the time step of the look ahead or how long the time of the look ahead, and all of these can be changed. Recall, as I mentioned earlier, this scenario was solved because it found a solution file. You can always execute a scenario again, but be warned, it may take time. Let's show you the mechanics of executing a scenario in the same GUI. I will go up to my Simulation tab, and I will hit Execute. Just as I warned you a moment ago, running these simulations can take a long time, so there is a brief warning asking you if you are sure that you want to overwrite the data that you currently have in your solution file. In this case, for this example, let's rerun the PCM peak demand week scenario. If I want to see what the simulation is actually doing, I can open my log window. Here I can see important information about what is happening and what the solver is actually encountering during the execution of this simulation. Here I can see this DC-UC-OPF simulation completed successfully. Now time for a quick knowledge check. What's wrong with the following sentence? Hey, come look at my production cost modeling network. Think about it for a second. The answer is that in Synced, production cost modeling is specified on the scenario layer. So it would be more correct to say, hey, come look at my production cost modeling scenario. This may seem like splitting hairs, but it can be really helpful to have precise language when you're communicating with your fellow users on the forum or when you're getting support from encoord. Quick question. How can I change object property values over time within a simulation? This is something we haven't covered yet. To do that in Synced, you use events. And in my opinion, events are really where the magic happens within Synced. They are incredibly core to the Synced mindset and philosophy. Events belong to a scenario. The event definition from the documentation is a change in settings, controls, or constraints of an object at a specific time during the execution of a scenario. Events are characterized by a start time, which describes at what execution time the event should be considered, a parameter, which defines which boundary condition of the object should be changed, and a value, which indicates which value should be set for the event parameter. Remember, before we talked about network property types, here we're introducing event property types. An event property is what's being changed by the event. Now, what if you don't specify a value? Will Synced just fail? No, because there are event default properties, and these specify the default event property value. Don't worry if you're confused right now. We will do an example to clarify in a few slides. How do I find the event properties in the GUI? Well, just like any properties in Synced, we can start with the property editor. So let's open the property editor for the Simmons generator. I'm going to click on the Simmons generator. Event properties can be found by clicking on the Events Property button within the property editor. You can always toggle on and off the headings using this button. Here we can see an exhaustive list of all the event properties for the Simmons fuel generator. For example, we can see the maximum active power event property, or the Pmax event property, and its corresponding default Pmax def. Let's run through that example that I just mentioned. So with the Siemens fuel generator open in the property editor, I can see that its Pmax is 250 megawatts, and that is currently being set by its Pmax def, so its default value. Let's change Pmax def, the default value for Pmax, to be 300 megawatts. So I'm going to go in and edit my default Pmax value to be 300 megawatts. I see instantly the Pmax value is updated. Again, that's because Pmax is being set by the default value. Continuing this example, now let's use an event to set that Pmax value to be 350 megawatts. To add an event to the Siemens generator, I'm going to right-click, scroll down to Scenario Event, and add a Pmax event to this scenario. And now I need to tell Sync that what, when, and how of this Pmax event. Specifically, I'm going to say that the Pmax parameter needs to be set to 350. The when of the event is just going to happen at the start time of the scenario. And now, when I come back to my property editor, I can see that the Pmax value is 350 megawatts, which is being set by that Pmax event I just defined. Now, a lot of people wonder why this functionality would be helpful. Well, as a simple example, you could use the Pmax def to capture the generator's nameplate capacity. And you could use Pmax events to capture derating periods throughout the course of your simulation. So just as events belong to a scenario, profiles also belong to a scenario. Profiles are how Saint handles time series data. Specifically defined, a profile is a collection of ordered equidistant data points that includes information on how these data points are processed in terms of their time step, the interpolation between the points, sampling, and periodicity. Let me show you the profiles in the Saint graphical user interface. With a network and scenario open, I can go up to the Scenario tab and click on the Profile button. Hiding my property editor, I can see that this scenario has many different profiles that all represent demand shapes and different operational considerations that vary throughout time. Now, I have a question for you. How can I tell Sync to use a profile to set object properties that change over time within a simulation? The answer is events. Events are where the magic happens. Events are how we tell Sync to change specific things throughout the course of a simulation. So now let's look at an example of an event that uses a profile to set values. Here's the profile table we were looking at before, and specifically I've highlighted the Rhode Island demand shape profile. We can see that this is a normalized profile that maxes out at 1. Let's look at some events that use this profile. I'm going to click on my event table and look for an event that uses the Rhode Island demand shape. Here's one. Let's break down this event. This event sets the pset value for the Providence demand, electric demand object. It uses the Rhode Island demand shape profile that we were just looking at before. And because it's a normalized profile, it scales all the values by the pset def property of the Providence electric demand. If we were using a non-normalized profile, we would have a value of 1 to indicate that no scaling would be applied. In the rest of this table, you can see many other examples of events that are using profiles to set object property values throughout the simulation. I hope you've enjoyed the third video in the Saint 101 video series. In the fourth video, we're going to bring all these concepts together and show a basic workflow in Saint.